Today we're going to be graphing and writing equations of circles in terms of conics. Our objective is to find the center and radius, to be able to graph a circle from standard form, and to be able to write the standard form from given information. So first, what are the parts of a circle that we're going to be concentrating on? The first thing is the center, which is actually not on the circle, the radius, which helps us find the circle, and x comma y is going to represent any point that's on the circle. Remember, the circle is actually this green part around the outside. We just use the center and radius to help us find it. And when you actually graph it, what I'm going to want you to do is plot a point for the center, and then the easiest way to do it is to go north, south, east, and west, the distance of the radius, put 4 points, and then try to draw a circle around that. Now when you're drawing this, try to actually have it curved. A lot of students kind of make it look like a square, so actually try to curve it so it actually looks a little bit more like a circle. So our standard form of a circle is very similar to some of the parts that we've seen before for our parabola. We have x minus h quantity squared plus y minus k quantity squared equals r squared, and r is our radius. Now if you notice here, we now have a h that's squared and a y that's squared. Before we only had one or the other for parabolas. And again, r stands for our radius. So again, r is our radius. Okay. And then h and k are our center. And we're going to use these over and over again. Now the reason it looks like this equation, I'm going to go back one screen just so you can kind of see, but when you have a circle, any point on the circle we can get by forming a right triangle. You don't have to draw this in, but and remember, in a right triangle we have a squared plus b squared equals c squared. And if we have all of these right triangles, if I pick any point inside the circle, okay, I can draw all these right triangles. If I pick this point here, I can get a right triangle here from the center. If I pick a point here, I can get a right triangle here from the center. So a center is really all the points that have the same hypotenuse length, and that gives us our circle. And that's why our standard form looks like a squared plus b squared equals c squared, where c is our radius. So we're going to go through and graph a couple of these. The first thing we're going to do is make sure it's in standard form. Now if I look at this one, it's not in standard form yet because I don't have my typical x squared plus my y squared part equal to my r squared. So the first thing I notice is that the x's and y's aren't on the same side. So what I'm going to do is leave my x's here first, but now I'm going to add this whole term over. So this is going to become a positive 4 y minus 6 squared. What some students do wrong is they change this to a plus 6 when they move it over. Remember, it's one big term, so we're just changing the sign of the entire term. And now when I get here, I'm really close, but I'm not supposed to have anything in front of my parentheses. So if I divide everything by 4, I'm left with an x minus 1 squared plus y minus 6 squared equal to 4. Now my center we find just the same way we did with parabolas. We do the opposite of what's with the x, the opposite what's with y for my h and my k, and my radius, well, if I know r squared is equal to 4, I know r is 2. So to graph this, I'm going to go to 1, 6, and put a little point, and then the points that are actually on my circle would be up 2, right 2, down 2, and left 2 from there. And now all I'm going to do is just try to connect them in a circular form to get my circle. And that's all you need to do. My next equation is pretty basic as well, but I can tell it's not my standard form because remember I want my x squareds plus my y squareds equal to my r squareds. But the only way I'm going to do that is to get rid of this 9. So I'm going to multiply both sides by 9 to clear my fraction. So this leaves me with x plus 2 quantity squared plus y squared equal to 36. Now remember, we don't have anything added or subtracted to y, so remember that just means 0, but I'm going to get a negative 2 comma 0 for my center, and my radius is going to be the square root of 36, which is a 6. Now if you remember when we did the actual algebra before, whenever you took the square root of both sides, we got a plus or minus. But it doesn't make sense to use the negative in this case because you can't have a negative distance, so that's why we just deal with the positive. So I'm going to go to negative 2, 0, and then I'm going to go right 6, down 6, okay, up 6, and left 6. And again, try to do your best to try to make it curve. Sometimes it's better if you do it in each of the little quadrants and try to curve it around. And there's your circle. So I am going to give you some problems just to practice where I just give you some important information. So the easiest thing I can give you is the center and the radius, because those are the only two pieces of information you need. So if I'm going to go backwards and write the answer, this is going to be x plus 5 quantity squared plus y minus 2 quantity squared equal to, now remember we have to square r. Well, if r is square root of 7, if I want r squared, I have to square root 7, which is just 7. If I look on the second problem, anytime I have a 0, we don't typically write x minus 0 or y minus 0. We just write x. So x squared plus y minus 3 quantity squared equal to, and again, if I want to square r, I have to square the 16, which is 256. And that would be your final answer. Please get in the habit, if there's no value, no number, like it's a 0, just write the variable. Okay, again, because you will never see it written in any book or any test with the minus 0. So now I'm going to give you two examples of a center and a point on a circle. So now remember, our center is our h and our k, and a point on the circle is our x and y. So you might have a hard time to think of where you're going to start, but we know, you don't have to write this part now, you can just wait, but what I do know is that my equation is x minus 3 quantity squared plus y squared equals r squared. Just from this one piece of information I can write all of that. So the problem is I don't know what my r squared is. So we're going to actually use the equation itself to help us out. Now the standard form of our equation is x minus h squared plus y minus k squared equals r squared. Well, I know what the x and h is, so I know my first parenthesis is x minus h. My second parenthesis is y minus k, or 4 minus 0. Now I'm just going to do the algebra. 9 minus 3 is 6 squared, which is 36. 4 minus 0, so we get our 4 squared, which is 16. And remember, all of this is equal to r squared. Well, what is r squared? Well, 36 plus 16 is 52. A big mistake that students make is they try to take the square root of that, but remember, our equation, our formula has an r squared at the end, not r. And that's all you need to do. So if I look at my second problem, and if you want to pause it and try to do this on your own and see if you get the right answer, you can do that now. But I'm going to start off, I know my answer is x minus 8 quantity squared plus y minus 1 quantity squared. But again, I need to know what that r squared is. So I'm just going to go back to my formula. Here's my h and k for my center, and here are my x and y, a point on the circle. So the equation says I'm going to do x minus h, so 3 minus 8 squared plus, then it says do y minus k, or negative 4 minus 1 quantity squared equals r squared. This is negative 5 quantity squared plus negative 5 squared equals r squared. So 25 plus 25 equals r squared. So I get an answer of 50. Okay, and just be careful with your signs. X minus h, and then negative 4 minus 1. And then that would be our final answer. So what if I change it up a little bit? What if I give you the center again, which is really easy, because if I give you the center, you're almost done with your problem. X minus 8 quantity squared plus y plus 7 quantity squared equals. So the only thing I don't know is my r squared. So what does this tangent to the y-axis mean? This is getting into a little bit of our geometry. So I'm just going to kind of draw a little coordinate plane, and I'm just going to put my point 8, negative 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. And that is my center. Tangent to the y means that when I draw this circle, it's just going to touch the y-axis. Okay, it's just going to bounce right off of it. It's going to be perpendicular to it. So if you remember from geometry, if I draw this line to my y-axis, it's going to be perpendicular. Well, that's just a radius. And this is really easy to tell the distance, this horizontal distance. So if this is at 8, negative 7, and I want to go all the way back to the y-axis, this is a length of 8, which means my radius is 8. Well, if the radius is 8, r squared is 64. And that's all you need to do. So again, here's a second example. If you want to try it on your own, you can pause now and see if you can get the right answer. But I'm going to go through it if you don't pause right now. So this is going to be x plus 6 quantity squared plus y plus 2 quantity squared equals, and again I want to find my r squared. Some students are going to be able to do all this without drawing it, but I highly suggest on any quiz or test, take the time to draw it out, because it's not worth making a mistake, because you want to save a couple of seconds. -6, -2, and I'm going to put my center. But now I'm tangent to the x-axis, which is right above us. So this means my circle is just going to touch that, which means if I draw the perpendicular, which happens to be a radius, that's a distance of 2. So my r is 2, which means my r squared is 4. And that's what our final answer would be. Okay, sometimes just a small little sketch can help make sure you make the right decision for your final answer. For 5 and 6, I'm going to give you a little bit different information. I'm going to give you the endpoints of the diameter. This is probably the longest problem. It's actually not that hard. It's one more step before doing what we did a couple problems ago. But some students get confused by it, and I'll try to go through it slowly so you can see what I'm doing. Remember, when you have a diameter, if I drew a circle, and I'm just going to draw any circle, the diameter is the point that goes through the center. So I have some center right here. Now I know the endpoints are 4, -3, and -6, 11. Now you don't have to draw them exactly where they are, but if I pretend I know 4, -3, and -6, 11. I know 4, -3 is to the right and lower, and -6, 11 would be to the left and up. So let's pretend like this is my diameter. Okay, so this is my 4, -3, and this is my -6, 11, just so you kind of have an idea. Alright, so what is the most important thing to find? Well, the most important thing to find right now is this point right here, the center. Everything lies around the center. And if you remember from geometry, to find the center between two endpoints, we just use the midpoint formula. Now, most students are like, oh, I don't remember what the midpoint formula is. But the idea of a midpoint is just an average. Well, hopefully you remember how to find average. If you want to find the average of two numbers, we add them and divide by 2. So, to find the average of the x, I'm going to take -6 plus 4 and divide it by 2. If I want to take the average of the y's, I'm going to take 11 minus 3, or plus a -3, we'll do that, divided by 2. The left-hand side is -2 divided by -2 divided by 2, which is -1. 8 divided by 2 is 4. So my center is -1, 4. Well, if I know that, I have most of my answer. I know it's x plus 1, quantity squared, plus y minus 4, quantity squared, equals r squared. Well, how do I possibly find the r squared? Well, I know a center, and I have a point. It doesn't matter which point. We could do the same exact strategy we did a couple problems ago. This is my center, my HK. Here's a point, xy. So I'm going to take x minus h, so 4 minus a -1, quantity squared, plus y minus k. So let's draw that again. Which is -3, minus k, which is 4. Quantity squared equals r squared. So this is 5 squared, or 25, plus -7 squared, which is 49. So if I have 25 plus 49, which is 74, and that's my r squared. And there's my final answer. So we just actually need that one extra step of finding the center by using the midpoint formula, and then we can use our strategy of using the center HK and a point XY. So again, if you want to try one on your own, you can pause right now. If not, I'm just going to go through it, and you can see what the second one is. Now you don't really have to draw this out. If I know these are the endpoints, I know the center is right in between them. So I'm going to take the average of the x's, comma, the average of the y's, and I'm going to get my ordered pair. 14 divided by 2 is 7, 6 divided by 2 is 3. So my center is 7, 3. From there, I know this is my h and my k, and I can pick any point. It doesn't matter which one. I'm going to use the one with 0 just because it's a little bit nicer. There's my xy. So if I take x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, I can find my r squared. I have my center, and I'm done. -1 quantity squared plus -3 quantity squared is my r squared. So 1 plus 9 equals r squared. So my final answer, my center, I'm going to get x minus 7 quantity squared plus y minus 3 quantity squared equals 1 plus 9, which is 10. And that would be my final answer. And then if I asked you to go on further, you could find the center and radius and graph it. Our last two equations deal with going from general form to standard form. And we had to do this with parabolas already. And it deals with the concept of completing the square. But now I need to complete the square for both the x variables and the y variables, because in my standard form I have x quantity squared and y quantity squared. So what's this going to look like? First thing I want to do is move the x's and the y's together. And if I notice, there's an imaginary 1 in front of the x squared and an imaginary 1 in front of the y squared, which means I'm going to be able to do completing the square without doing any extra work. So I'm going to put the x's together, x squared minus 2x, and because I want to complete the square, I'm going to put plus blank. Okay. Plus, now I'm going to go to the y's. I have a y squared plus 6y, and again I want to do plus blank, but I have this plus 4. It doesn't have an x or a y, which means it's all by itself. I'm just going to move it to the other side, which makes it negative 4. But because I wanted to add a blank for the x's and a blank for the y's, I'm going to need to do that on the right hand side as well. Hopefully you remember, for completing the square, we want to find half of the b term, which would be negative 1 quantity squared. And remember, if you square that, that means I'm going to be adding 1 to both sides. And for the y's, I'm going to do the same thing. I'm going to take half of my b value, which is half of 6 is 3, quantity squared. If I square that, I'm going to get 9. I'm going to add 9 to the other side. And that's going to equal negative 4 plus 1 plus 9 is 6, and that's my final answer. So again, just to write it out so you can see it, x minus 1 quantity squared plus y plus 3 quantity squared equals 6, and that's my final answer. So we're going to go through one more, our last one, and if you notice, I have a number in front of x squared and y squared, and you can't complete the square with that. So what I like to do is I like to just get rid of it right away. We're going to do a little bit different strategy when we're dealing with hyperbolas and ellipses, but circles are nice and easy because a circle has the same, since it's so symmetric all the way around, the lead coefficient in front of x squared and y squared always have to be the same, so we can always just divide it out right away. So x squared plus y squared minus 6x minus 8y plus, and this is going to give me 24, equals 0. Remember, it's okay to have 0 in the numerator, just not the denominator. So now I'm going to do the same thing I did before. I'm going to put the x's together, x squared minus 6x plus blank, plus, and now I'm going to go to the y's, y squared minus 8y plus blank, equals, and then I want to move this 24 over to the other side, negative 24. Make sure you change the sign. But I need my blank for the x's and the blank for the y's. So for the x's, half of negative 6 is negative 3. Okay, to complete the square, I'm going to add 9 to both sides. And again, remember, this works because negative 3 times negative 3 is 9. Negative 3 plus negative 3 is negative 6. Okay, the y's, half of negative 8 is negative 4. Quantity squared. Again, if when I square this, I'm going to get 16. I'm going to add 16 to both. Equals negative 24 plus 9 plus 16 is 1. So just so you can see it better, my final answer is x minus 3 quantity squared plus y minus 4 quantity squared equals 1. Again, if I asked you to graph this, you'd be able to tell me the center was 3, 4, and it had a radius of 1, because the square root of 1 is 1. I hope you feel a little bit better about graphing and writing equations of circles, and I hope you feel that you're able to find the center and radius, you're able to graph a circle in standard form, and you're able to write the standard form from given info.